So let's take a little example about uncertainties and do a full measurement or a full example about how you use uncertainties. And then in the next slide we'll talk about the general rule, which you will mostly use. But I think it's a good idea to show you how the uncertainties are used. So let's say we have some sort of area here that measures 11.3 centimeters wide, 6.8 centimeters tall, or in length and width, and we're trying to find the area. And more specifically, what's the uncertainty in the area if we know this one is 6.8 and this one's 11.3. So the area is given by this formula, A equals L times W, or length times width, right? So we have a length of 11.3 centimeters. We have a width of 6.8 centimeters. And you plug that in your calculator and you multiply it through, you get 76.84 centimeters squared, right? If you take centimeter times centimeter, we get centimeters squared. Now, if you just take this number, this says that we have an uncertainty of 0.01 centimeters squared. Now, is that correct? Well, no, or otherwise we wouldn't be showing you this example. If you want to truly find the uncertainties, what you do is to find the min and max values. So to get the minimum value of L, of the area, we take the minimum value of L times the minimum value of W. We get the smallest value for A. To get the maximum value, we take the maximum value of L, the maximum value of W, to get the maximum value of A. So in L, we have 11.3. So that means we assume that the highest number it can be is 11.4, and the lowest number it can be is 11.2. And in this term here, 11.8, the width, we assume that this could be 6.9 as the highest value and 6.7 as its lowest value. So our minimum of A could be 11.2 times 6.7, or the two smallest values, giving us this number. And our maximum value can be 11.4 times 6.9, giving us this number here. So what we see here is that actually our number has to be in between here, or the average value, which is 77 centimeters squared, with an uncertainty of this value here of 1 centimeter, or 1 centimeter squared. So here we only have two significant figures and a 1 centimeter squared, where here, when we wrote this down, we had 4 significant figures and 0.01 centimeters squared uncertainty. This is the correct value. Now consider the case where we have some value, not our area, but some value A is equal to L over W. Now, to get the minimum and maximum values, we'll have to switch these around a little bit, right? To get the maximum, to get the minimum value for A, say, then L is going to have to be the smallest value and W have to be the largest value. To get the maximum value for A, then L will have to be the largest value and W would have to be the smallest value. So in this way you can go through pretty much any problem if you figure out how to get the maximum and minimum values for each one. Okay.